Hello everyone, this is Anon from Anon Math channel. In today's video, we're going to take a look at a simple but interesting algebra problem. We want to find a cubic equation with integer coefficients whose root is 3 times cube root of 2 minus 1. So basically, we want to find a cubic equation in the form of ax cubed plus bx squared plus cx plus d equals 0, such that a, b, c, and d, the coefficients of the equation, are integers, and x equals 3 times cube root of 2 minus 1 is a solution for this equation. So that's the goal of the video, but the question is, how can we do that? Well, let me give you an idea. Suppose that we have 4x minus 8 equals 0. We can easily manipulate this and solve for x. We can first add 8 to both sides, so we get 4x equals 8. Next, we can divide both sides by 4 to get x equals 2. So we can manipulate the given equation and solve for x, but the thing is, we can do the opposite too. We can use the given solution and manipulate it and find a corresponding equation to this solution. For this case, if x equals 2, we can multiply both sides by 4, so we get 4x equals 8. Next, we can subtract 8 from both sides, and we get 4x minus 8 equals 0. So this is a corresponding equation for this solution, and of course, there are infinitely many corresponding equations for this solution, but in our case, we just want to find one cubic equation, one corresponding cubic equation with integer coefficients, which corresponds to this solution. So what I'm going to do, I'm going to go ahead and use the given solution, and I'm going to manipulate it to find a cubic equation. So we're given that x equals 3 times cube root of 2 minus 1 is a solution for our equation. So I'm going to manipulate this to find a corresponding equation to this. To do that, first of all, I'm going to add 1 to both sides. So I get x plus 1 equals 3 times cube root of 2. And the reason I did that is that we know that we want to find a cubic equation with integer coefficients. So we don't want to have a cube root of something. We don't want to have a cube root of 2. So I need to remove this, and to do that, I isolated 3 times cube root of 2 by adding 1 to both sides, and next I'm going to cube both sides to remove the cube root. Great. Now I'm going to use the binomial theorem to expand the left-hand side out. So I get x cubed plus 3 times x squared plus 3x plus 1 equals 3 times cube root of 2 all to the power of 3. Now notice that this is a product, so I can distribute the power over the product. So I get 3 cubed times cube root of 2 to the power of 3, and that equals 27 times 2, because cube root of 2 to the power of 3 is going to be 2, so we have 27 times 2, which is 54. So we found out x cubed plus 3x squared plus 3x plus 1 equals 54. And now if we move this to the left-hand side, we should get x cubed plus 3x squared plus 3x minus 53 equals 0. So this is our cubic equation with integer coefficients whose root is 3 times cube root of 2 minus 1. And this brings us to the end of this video. Thank you for watching this video. As always, if you enjoyed watching it, click like and click subscribe for more content. Goodbye, and I will see you later in another video.